Hey, what's up? It's your old pal, Mr. Cook. And let's see, we're going to work on this AP Calculus BC final exam review. We got through the first 19 questions. Now we'll do, I guess, these ones. Oh, and then we're going on to integrals. So we'll do a bunch of those too. Okay, so starting with number 20. 25-foot long ladders leaning against the wall of a house. Base of the ladder is pulled away from the wall at a rate of, I got to draw this out. Let's see. So it's a ladder, 25 feet against the wall. There's the ladder. It is stuck at 25 feet. Leaning against the wall of the house. There we go. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So it's going in this direction, 2 feet per second. How fast is the top of the ladder moving down the wall? Because, yeah, if it's pulled out from under it, the ladder's going to be going this way, right? So if this is the x direction, this is the y direction, this is going to be a change in the x direction over time. And this is what we're looking for, is a change in the y direction over time. So how do we relate the variables x and y to 25? You know, it's a right triangle. So we use Pythagorean theorem. So x squared and y squared is going to be equal to 25 squared. So let's see. We want to find how fast the ladder is moving down the house when the base is 15 feet from the wall. So in other words, when x is equal to 15, that's going to be like the specific moment that we're talking about. So in a related rates problem, usually what happens is you get like an implicit differentiation problem. You take the derivative with respect to time, and then you just plug stuff in and solve it. Okay. So, you know, we've got our implicit differentiation problem, x squared and y squared. So we take the derivative. So derivative of x squared is 2x dx dt, because it's going to be taking a time derivative with it. And then y squared is going to be 2y dy dt. And then the derivative of a constant, even if it's 25 squared, it's still going to be 0. Okay, so now we can start plugging some stuff in. We know what the x value is going to be in this case, so that becomes 2 and then 15. We also know that in the x direction, it's going to be moving 2 feet per second, so this change in time is going to be 2. We can find the corresponding y value, because if this side is 15, this side is 25, and this side is y, if we use Pythagorean theorem, y squared plus 15 squared is equal to 25 squared. And if you use your calculator for that, you'll end up with, I think, 20. So 20 should be the y value, so 20. And then we're looking for dy dt. So that's the last thing we got to solve for, that thing. So now it just becomes algebra and just solve for dy dt. So 2 times 15 times 2, that's going to be 60. 2 times 20 is 40. Subtract 60 from both sides. Divide by 40. And then, we'd probably reduce it. So those are both divisible by 20, so -3/2. So that's like the number that you should get. And then you should also have units. So just like the, rate of change here, it's going to be feet per second. But, it's going to be multiple choice, so you'll be able to see that pretty quickly if there's a related rates problem like that. Number 21, a boat is pulled into a dock by means of a winch 12 feet above the deck of the boat. Okay, so it kind of looks like this. Okay, so here's like the dock. And here's like a winch. And then it's like pulling a rope that leads to a boat. And here's my boat. Something like that. Here's the water. There we go. Okay, cool. So there you go. Suppose the winch pulls the rope in at 4 feet per second. So that means that it's going this way, 4 feet per second. 4 feet per second. There we go. Determine the speed of the boat moving horizontally when there's 13 feet of rope left out. So that means that, like, we'll call this variable r, the length of the rope. So this is going to be dr dt. And then it says that the winch is fixed at 12 feet above the deck of the boat. So like above the deck of the boat's here. So that means that it's going to make 12 feet here. So this is another, it looks like another right triangle. That length is fixed at 12. That means that this variable, we'll call it x, is basically like it's going this way, right? Because the boat's getting closer to water. So, that's what we should look forward to. All right. Okay, so the rope is going to be getting smaller. So it's going to be a negative. And also I should expect this what I'm looking for is like how fast the boat is moving horizontally. So I'm looking for this dx dt, and this thing should also be negative because the boat's moving closer, so the x value is getting smaller. Therefore, dx dt is going to get smaller. So it also tells me that the rope length is going to be 13 feet. So that's this 13. So I should be able to solve for x using Pythagorean theorem. That's going to be 5 right there. Okay, so how do all these things relate together? Well, r is one variable. It's going to keep changing. The rope length changes. X is going to keep changing because the boat keeps moving closer and closer towards the dock. But this length 12 is going to stay constant. So I can write up this Pythagorean relationship. X squared plus 12 squared is going to be equal to r squared. And if I take the derivative of both sides, I'm going to get 2x dx dt. The derivative of a constant is nothing, so 12 squared just becomes 0. And then derivative of r squared is going to be 2r and then dr dt. And now we can start plugging stuff in. So I know my x value is going to be 5 from the Pythagorean theorem. I know that dx dt is going to be a negative 4 feet per second. And then I know that r is going to be the length of the rope, 13, and we need to solve for dr dt. So this just becomes a simple algebra problem now. So let's see what happens here. 2 times 5 is 10. 10 times negative 4 is negative 40. 2 times 13 is 26. So that means that the rope is going to be moving in the following. It's going to be dr dt is equal to negative 40 over 26, which then reduces down to, because both those numbers are divisible by 2, negative 20 over 13. And then I forget the units. Oh, it's feet per second. So that means that the rope is moving in at 12/13 of a foot per second. Now, this also might be rounded. Okay, so remember to use your calculator and find out what that's going to be as like a decimal value, because it could be a decimal value, as a multiple choice answer. 22. So yeah, this looks like it's going to be, a rational function, but in reality, I always train my kids to change any radicals into exponents. So this just becomes x over, and then the square root of x is x to the 1/2, and then to the 7th power means that it's x to the 7 over 2. And then you can kind of see what to do here. You can reduce this, right? Because this is x to the 1st. So if you take away an x from the top and the bottom, you'll end up with 1 over x to the 5/2 power. And then I also train my kids to not just rewrite it as an exponent, but also if you have an exponent in the denominator, change that to a negative. So then this also becomes integral of x to the negative 5/2 and then dx. Now this is just a power rule problem. So we add 1 to the exponent power, so that's going to be a negative 3/2. And then we divide by that number, negative 3/2, and then plus c at the end. Now this is how I tell my kid, would tell my kids, stop here if it's a free response question. But if it's multiple choice, you'd have to maybe make it look a certain way, right? Simplify it a bit. So if I divide by a fraction, it's the same as multiplying by the reciprocal. So this becomes a negative 2/3. And then x to the negative 3/2 power, I might move that to the denominator. So it might end up looking like this. Negative 2 over 3, and then x to the 3/2 power. So it could look potentially like that. And then, plus c obviously for that as well. All right, so, it might look that way. 23. Something and then times e to the something power. So I always think about it in a couple different ways. I did an algebraic manipulation here and just used the typical rule, the power rule. But really, you should be going like this. Think to yourself, is this a memorized rule? That's the first thing that should cross your mind. The second thing should be a u substitution. If it's neither of those things, try to use some algebra with it. So what I mean by using algebra is simplify it maybe, or use a trig substitution or a trig identity, or you can use partial fractions here, to simplify it, right? So those are all the things I think about the algebraic stuff. And then number 4, I try to see if it's another memorized rule or a u sub again. And if none of that works, then I go to my last option, which is going to be integration by parts. So that's kind of what I go through mentally for every integral problem. I just do it really quickly because I can process it really quick because I've done a million of these. When I looked at this problem, I knew it was a u sub right off the bat. I would skip through the memorized things because there's no memorized rule that I had for that. I go right over to u sub. So in a u sub, it's a composition, so a function inside of another one. And this is the function that's inside of the e to the somethingth power function, right? So I'd first try to make that a u sub. I'd let u be equal to x squared plus 3x. And then, I'd take the derivative. So du is equal to 2x plus 3. And then I'd try to see if 2x plus 3 dx is, somewhere in there. And it is, right? Because 4x plus 6 is really 2 times 2x plus 3. So I can make like a clear substitution here because I can take that 2x plus 3 and that dx and turn it into a du. So here's what this ends up turning into. This, is really 2 times that, right? So I can take this and this, turn it into a du. And then I still have this 2 left over, so 2. And then I've got e to the power of, and that becomes u, so e to the u. And this is like a really easy antiderivative to take. It's going to be, 2 e to the u power and then plus c. And then we just replace the u back in there. So it'll be 2 e to the power of x squared plus 3x and then plus c. And that's probably how it would look on, as a multiple choice question. 24. So 24, I go through my list. This is an easy memorize rule. Doesn't look like it. Is it a u sub? I don't know. Let's find out. So, I'd see that there is a function inside of another function. Natural log is raised to the second power. So I would let u be equal to natural log of x. And then du, the derivative of natural log, is 1 over x dx. And check it out. I've got a 1 over x right here and a dx here. So that whole part can just become a du. So I'm going to rewrite this so it's a little bit more obvious to see. This is the same thing as saying 1 over x times 1 over the natural log of x squared dx, okay? And that's why I can now plainly see that I've got a 1 over x and a dx here and here. So if I'm doing my u substitution, I would substitute that in for a du. And then 1 over the natural log of x, that quantity squared would be 1 over u to the second power. And, just like I would train my kids with this, my students, I would make sure that becomes a negative exponent because then it's a little more obvious about, what I'm going to do. I'm going to be using power rule for this one. Okay, so if I use the power rule, I add 1 to the exponent power, so that's u to the negative first, and then I divide by that number, and then plus c. And then maybe I'd make this look a little bit nicer before substituting back in my u. So that'd be a negative 1 over u plus c, and then I'd plug u back in, so that's natural log of x. So negative 1 over the natural log of x, and then plus my constant. So that's how my antiderivative would look for this one. Let's do a couple more. I'll do 2 more. 25, x squared e to the x. This is very obviously, if you've done a bunch of these, you know that this is going to be a integration by parts. But, you go through the list. Hey, is there any memorized rule for this? No. Is this a simple u substitution? No. Can I do any algebra with it? It literally looks really simplified, so I don't think so. So then I just go right into integration by parts. And I know this is integration by parts because, if you work through this problem a couple of times, you see you just got to do integration by parts a few times to get rid of the x. And then the e to the x will just, be the last antiderivative that you take. So, you remember the pattern. You have to memorize the pattern for integration by parts. If you have an integral u times dv, it's equal to u times v minus integral, excuse me, v times du. Okay, so you have to establish what the u is going to be. And Mr. Rupp showed me this really cool way to memorize which function to use for the u, and it's this. You just remember one nonsensical word, late. It's like the word late with an I right after the L, right? So what this means, what this helps to remember is your order of importance for the u part, okay? So L stands for log or natural log. I stands for inverse trig. A stands for algebra, so that would be x squares, x to the thirds, 5x to the fifth or something, any of those things. T is just going to be regular trig expressions, and E is regular exponential expressions. Well, and yeah, if we go in order of importance, there's no natural logs or logs, there's no inverse trig, but there is an algebraic expression, x squared, right there. So that's what I'm going to let equal u, and then dv is going to be the rest of it. So it's going to be e to the x dx. Okay, so then I find du and v, so that's going to be 2x dx, and then v is going to be equal to e to the x. And then I just use the pattern, to find out what that is. So x squared times e to the x, and and then dx is equal to, so I'm just repeating that, equals, and then it's going to be u times v, so u times v, so x squared e to the x, and then minus integral of v to u. So it's going to be these two. So it's going to be, I'm going to rearrange it a little bit, 2x e to the x dx. And I can't just take, an antiderivative here. So I got to use integration by parts one more time here. And I use the same rule, Lie, and it just so happens that the same thing. I just get an algebraic expression as the one that I'm going to set equal to u. So let u be equal to 2x. That means that dv is going to be equal to e to the x dx again. That means that v is equal to e to the x again. And it means that du is just going to be equal to 2 dx. And that's the last time that we're going to have to use integration by parts. From there, it'll be a really easy antiderivative. Okay, so that means that, rewriting all this stuff, x squared e to the x dx is equal to x squared e to the x minus, and now this antiderivative gets the same treatment, u times v dv is equal to uv. So these two multiply together, so that's going to be, and let me put a little box around this one. So that's going to be 2x e to the x minus integral of v du. So that's going to be 2 e to the x dx. Okay, now this is pretty easy to, work through. 2 e to the x dx, that's just, the antiderivative, that is just 2 e to the x and plus c, right? And then we have to distribute the negative in here. So let's see, if we distribute the negative, this becomes negative, and then a negative of a negative turns into a positive. And then the constant is just going to keep changing. You can go from positive to negative or whatever, but like that'll be our antiderivative right over there once we're all done. You could do the tabular method. I'm not going to go over that in this video. And remember that you just got to be careful, when you're reducing it down until you get to a 0, okay? 26, evaluate x sine of 2x. Okay, this is another integration by parts problem. There's no easy rule to remember. There's no trig substitutions or anything like that. For the algebra, there's no, obviously, u substitution. So it's just integration by parts. So you go through the same thing as before, Lie. There's no natural logs or logs on that one. Oops, sorry about that. There's no logs or natural logs. There's no inverse trigonometric expressions, but there is an algebra problem, x. So that's what we're going to let equal to u. So let u be equal to x. That means that dv is the rest of the stuff. It's sine of 2x dx. So then we take our derivative of u. It's going to be just 1 dx. We take the antiderivative of v. Antiderivative of sine is negative cosine. And this is going to be like an easy u sub to take this antiderivative. You just got to divide by 2 or multiply by half out front to take care of that 2x. Okay, so remember that the pattern is integral of u dv is equal to u times v minus integral v du. So this is going to be equal to u times v. So u times v is this, and that would give me a negative x over 2 cosine of 2x minus integral of v du. So these two multiply together. So that's going to be, that's easy. That's just a negative a half cosine of 2x and then dx. Okay, well, a negative and a negative makes a positive. I'm just going to move that plus out front. There we go. And then this is actually a pretty easy antiderivative. This is just another really basic u sub. So, if you know the shortcut for that, here's how it looks. Okay, so plus, and then antiderivative of cosine is just sine. So it's going to be sine of 2x. And then it's got that 1/2 out front, but then it's also going to get another 1/2 from the chain rule, the u sub from that 2. And 1/2 times 1/2 is 1/4. And then we still have to add plus c at the very end. So that's how the antiderivative should look for this one. Okay, so that's all the way through number 26. I think that's a good place to stop for this one. Then we'll make another video going over the next, looks like we got some partial fractions here. And does that one factor? It does. So that'd be another partial fractions problem. That one is just going to be, that's just a u sub, and then using a definite integral. That one's another u sub using a definite integral. That's wait, that's right. I should probably check. Are these indefinite? Oh, yeah, that's right. So I'm not allowed to use 1 here. So this is actually going to be an improper integral. So I got to take note of that. What about 28? 28 wasn't definite. So this is improper. And then, 2 also, I can't use that. So this is improper. 31, I'm not allowed to use 0 in the denominator, but that's not part of the domain. But this does become infinity, so I need to evaluate that. I think I'll probably do those 3 together. Yeah, so I'll do the partial fraction ones together in one video, the improper integral ones together in one video, and then, just kind of work from there. How many problems are there total in this? So I anticipate making we're pretty close to the end. I'm probably going to make 4 or 5 more videos. That's it. And so look for those for another time. I think I'm just going to call it a day for now. Okay. Yeah. So I'm done with this video. Got through number 20, 26, I think. So through 26. All right. Well, I hope you found this video helpful. If you didn't, just reach out to your calc teacher, get some help from them. I'm Mr. Cook. If you ever need any help, just find me. I'm usually available in the morning and also after school. And I'm always, always, always willing to help out. Okay. Thank you very much for watching. I hope to see you in the next video. Bye-bye.